So when we discuss these Lewis structures, we also have to deal with many of these exceptions or different situations that come up. And the first one is octet exceptions. So there are sort of three things where when I'm done with my Lewis structure, an atom within the Lewis structure will not have octet. It won't have 8 electrons, or even a duet for hydrogen. So the first kind is something called free radicals. Sometimes the structure that we have, which is a real life thing that the molecule exists, has an odd number of electrons. You cannot have, no matter how much you move around things, you cannot write a good Lewis structure for a odd number of electrons. The fact that they exist and they're stable and it means that we do the best Lewis structure we can, and we're trying to understand what they really are. We won't see many of those in our class. However, we will see one with group 13 atoms. Boron and aluminum are the particular ones, especially boron. It tends to form compounds that only have 6 electrons rather than 8. So for instance, this boron with 3 hydrogens and boron with 3 fluorines tend to form, now again, remember this is a shared pair. I could have written a covalent bond line here. But when I'm done, the boron only has 6. We'll figure out that a little bit later why that's the case. But know that if you end up with 6 and it's boron in the center, it's okay. The one that we will see an awful lot of is elements in period 3 and higher having more than 8. So again, it has to be in period 3 or higher, because basically what's happening is these bonds, extra bonds, the ones beyond the 4, are using d orbitals to do this. So it has to be at least in period 3 to have those accessible to be able to use them. So in this case, this SF6 actually has 2, 4, 6, 8, 10, 12. Let's see, 2, 4, 6, 8, 10, 12. So 12 electrons rather than 8. This phosphorus here has 2, 4, 6, 8, 10 electrons instead of 8. And again, phosphorus and sulfur are both period 3 or higher, so it's acceptable. We're going to refer to these as expanded octets. So how do you know whether to just put 8 and have an octet or whether to use more? So the idea is that we invoke it when we need to. As long as you draw the Lewis structure and you finish placing your lone pairs on it, if you remember, you start with the outer atoms. When you finish putting 8 on all the outer atoms, you begin putting extra lone pairs on the center atom. If you have electrons left over, even though the center atom has 8 electrons, they have to go somewhere. If the center atom is period 3 or higher, you can add them on that center atom. So that's one way. Additionally, sometimes we just try to observe structures where we have a good Lewis structure, but maybe we might just see, could you make a resonance structure, which we haven't talked about yet, by moving more than 8 electrons, and see, would this be a preferred structure? So we'll do some of that as well. What I want you to now do is practice the Lewis structure of Xe03. We had already started this in class. Or I think we did, maybe we didn't. So I want you to begin with this, and we'll do, note that we have 8 electrons plus 18, so this has a 26 electrons, and you'll see that this is going to end up invoking that extra extended octet.